Hi, welcome to the continuation of Master Crammer Calculus Made Easy series, and the topic for this video is about limits of trigonometric functions. So, one of our basic examples for limits of trigonometric functions will be the limit of sine x over x as x approaches 0. One shortcut way of solving this is by substituting x with values as they approach 0. So in this case, if we can see here on the table on the left hand side, x is equal to negative 0.1, x equal to negative 0.010, and x equal to negative 0.001. So as you can see here, as x approaches 0 from the left hand side, what happens to f of x, which by the way is sine x over x? So f of x approaches 1. We have 0.99833, quadruple 98, and then 1. So as x approaches 0 from the left-hand side, f of x, which is sine x over x, approaches 1. Going now to our table to the right, if x approaches 0 from the right-hand side, let's see what happens. X is equal to 0.1, x is equal to 0.01, x is equal to 0.001. As x approaches 0 from the right-hand side, we can see here f of x, which is sine x over x, f of x approaches 1. So we can see here, as x approaches 0, sine x over x approaches 1. So guys, remember this. This limit of sine x over x as x approaches 0 is equal to 1. Now you know it's equal to 1. Just memorize it. No need to derive it. Just memorize it, because this will be used now in solving more complex limits on trigonometric functions. So limit of sine x over x as x approaches 0 is equal to 1. This is one of the basic limits that we need to memorize. Two more are coming, and this will be used to solve more complex trigonometric functions. Another basic trigonometric function is the limit of 1 minus cosine x over x as x approaches 0. So in this case, let me write it down. Limit of 1 minus cosine of x over x as x approaches 0. Let's multiply 1 minus cosine x by its conjugate, which in this case is 1 plus cosine of x. And then to make it equal to 1, we have to, the denominator should also be 1 plus cosine of x. So we can see here, numerator is 1 plus cosine x, denominator is 1 plus cosine x, 1 plus cosine x. This is also equal to 1. So in essence, you're not changing our original expression of 1 minus cosine x over x. Now we have here 1 minus cosine x multiplied by its conjugate 1 plus cosine x. If you recall, a squared minus b squared, which is the difference of squares, is equal to a plus b multiplied by a minus b. So a minus b is basically 1 minus cosine x, and a plus b is 1 plus cosine x. So we can see here, a is equal to 1, b is equal to cosine x. So therefore, 1 minus cosine x multiplied by 1 plus cosine x, we can convert this into a difference of two squares, or difference of squares. Since a is equal to 1, a is equal to 1, and b is equal to cosine x, we can now transform this into 1 squared minus cosine squared x all over x is x multiplied by 1 plus cosine x, 1 plus cosine of x as x approaches 0. Now, recall our trigonometric identity in the basic trigonometry. Recall that sine squared x plus cosine of squared x is equal to 1. So we can say therefore that 1 minus cosine squared x is basically equal to sine squared x. So let me just put some additional space. Let me erase this. So now we can see therefore that 1 minus cosine squared x from the trigonometric identity of sine squared plus cosine squared x equal to 1, we can see here that 1 minus cosine squared x is basically equal to sine squared x. So we can now substitute 1 minus cosine squared x with sine squared x. So we can rewrite this now as the limit of sine squared x all over x multiplied by 1 plus cosine of x as x approaches 0. Now let me put some more space here so it's easier to understand. Let me erase this. Let's put some more space so that because if it's a bit cramped, it's a bit difficult to understand. So now it's easier to understand. You have more space. Let me put it back to the pen. Now our equation, our expression is now limit of sine squared x over x plus 1 plus cosine x as x approaches 0. We can now rewrite this into the limit of sine x. So sine squared x is simply sine x multiplied by sine x. So sine x divided by, you have x here, multiplied by 1 plus cosine x as x approaches 0. So limit of sine x over x as x approaches 0 multiplied by this, limit of sine x times sine x all over x multiplied by 1 plus cosine x as x approaches 0. So if you recall from our limit laws, I can actually split this into 2. Therefore, I can rewrite this now into, let me just erase this. I can now rewrite this into the limit of sine x over x as x approaches 0 multiplied by the limit of sine x divided by 1 plus cosine x as x approaches 0. If you recall, the limit of a product of two functions f of x and g of x can also be expressed as the limit of the product can also be expressed as the product of the limit of the two functions. In this case, limit of sine x over x multiplied by sine x over 1 plus cosine x as x approaches 0 can also be expressed as the limit of sine x over x as x approaches 0 multiplied by the limit of sine x over 1 plus cosine x as x approaches 0. Now, this one is limit of sine x over x. As I told you, we have to memorize this because this will be used in more complex trigonometric functions. Limit of sine x over x as x approaches 0, this is equal to 1, if you recall. Now let's multiply this now by the limit of sine x over 1 plus cosine x as x approaches 0. Now substituting now x equal to 0, we will have here sine of 0 all over 1 plus cosine of 0. Now, this is equal to 1. Sine of 0 is basically equal to 0. 1 plus cosine 0 is equal to 1. So 1 plus 1 is equal to 2. But this is 0, so it's equal to 0 over 2, which is basically equal to 0. Therefore, the limit of 1 minus cosine x over x as x approaches 0 is equal to 0. So this is one of the basic limits, again, that you guys need to memorize. Limit of 1 minus cosine x over x as x approaches 0 is equal to 0. So this is the second basic limit that you guys memorize. It will be much easier to solve more complex trigonometric function limits if you memorize this, as well as the previous one limit of sine x over x as x approaches 0. Now, our final basic limit, again, that we need to memorize is limit of tangent x over x as x approaches 0. Let's try to derive it. But after deriving it, and you know the answer, memorize it, so you don't need to derive it in the future. Okay, so here, the limit of tangent x over x as x approaches 0, we can rewrite tangent x as, if you recall, tangent x is equal to sine x over cosine x divided by x as x approaches 0. Now, sine x over cosine x divided by x is equal as well to the limit of sine x over x. Okay, so we simply simplify this. So this will now be 1 over cosine x. Okay, sine x over cosine x, okay, is simply equal to this. Sine x over cosine x divided by x can be expressed as sine x over x multiplied by 1 over cosine x as x approaches 0. Now, this can be expressed as the limit of the product of two functions. So the limit of one function sine x over x multiplied by 1 over cosine x. If you recall, we can have here limit of f of x multiplied by g of x as x approaches a certain number can be expressed as the product of the limits of the individual functions. So we can write this therefore as the limit, let me try the blue ink. This can be expressed as the limit of sine x over x as x approaches 0 multiplied by the limit of 1 over cosine x as x approaches 0. Limit of sine x over x as x approaches 0, as we all know, is equal to 1. Whereas limit of 1 over cosine x is simply equal to 1 over cosine of 0, which is equal to 1. Therefore, we have 1 multiplied by 1. And final answer, therefore, is equal to 1. So we can say here, therefore, that limit of tangent x over x as x approaches 0 is equal to 1. So memorize these three basic limits so that we can use this in solving more complex trigonometric functions. I hope you guys learned some of these techniques, and we will be dealing with more complex techniques in the next videos. And please remember to click on the subscribe button below to take advantage of the latest Master Grammar videos. Thank you and sayonara.